Hello, everybody. Good morning, people. Please confirm if I am clearly audible. No disturbance, no cracking, breaking. All good. Okay, very fine. I had sent you the code yesterday. What we ran for your assignment. So far, what you have done is you have been through mm, a certain level of coding, a certain level of concepts, nitty-gritty terminology of data science, which is essential by the. Prior to that, you have been through SQL module. We have learned some things about databases, which is essential again. Data analyst or data scientist must know at least that level of SQL. You will be going beyond that in your session of Hadoop, obviously, but for now that is sufficient. Before I proceed, what do you say your journey has been so far? And Jyoti, is my voice clear now? I saw that you did not have audio connection. Okay, first things first, guys. Is my voice clear? And is my display clear? It should be coming as plain white, a notepad file. Is everything good? So that's for one. Very fine. So taken care. Jyoti, what is the problem? I see you are connected on web. Okay. While Jyoti connects again. Others, please, guys, it is time for a quick feedback. What do you think how your journey has been so far? You are almost 1 month along with me. Is it so? When did we begin? What was the exact date you started your modules with me? Can somebody, not exact date, maybe you can give me a rough idea, but it has been around a month, maybe more. Oh, it is way beyond a month. Very well. So, what do you say? How your journey has been so far in our module, particularly, I'm asking because guys, things are going to be a few notches up henceforth. We are entering the stage of predictive analytics. Remember, descriptive analytics, diagnostic analytics. So you have done your hands on there. Yes or no? We have been through this. Yes. So there are various types of analytics or various stages you may call if you wish to. So broadly, they are categorized as descriptive, diagnostic, predictive. One stage is prescriptive analytics. We will look into that. What is that? And then it goes beyond that. That is cognitive analytics, which is beyond the scope of this curriculum. So we'll not talk about that. But yes, what do you say? Why I don't see responses, people? You have already seen descriptive analytics. You have done some kind of diagnostic. What is diagnostic? When you try to question why something is happening. Remember, yesterday we tried to find out why something is happening, why there are missing values. Yes or no? Why this is happening this, why this is happening that. We try to answer these kind of analytics. So that is diagnostic. So now we are going into a stage of predictive analytics. See, by now we know what has happened. So that's what descriptive does. My data is explaining what has happened. Then I may question why something is happening. Why this is happening this way? Why can't it happen that way? So that is diagnostic analytics. What do you think would be the third question? What do you think going to be the third question? Your CEO was asking, okay, what you are doing, marketing team, you are using this budget and you are using this sales. What do I gain from that? So marketing answers, sir, this has been happening. You see this graph? We utilized marketing budget, this much amount, we ended up with this much sales. Then we increased our budget, we ended up with an increased sales. And month on month, you see, we are improving marketing budget, and month on month, we are saying that sales is gaining. Fantastic. Diagnostic analytics. Maybe CEO asked some question, or maybe it was not such rosy picture. Maybe it happened something haywire, and you are not able to explain that. So now CEO is asking, why this is happening this way? Why can't it happen that way? Why can't we do something else? So that is diagnostic analytics. Now we are trying to answer something. Why something is going wrong? Like in this case, remember that example? You remember that example? I talked about that. What if this picture was not that rosy? What if something this kind of thing happens? That sales is more or less same. Budget is increasing. Budget is constantly increasing, but sales is more or less the same. What is this kind of thing you happen to see? There will be questions. Yes or no? Why this is happening? When you are utilizing marketing budget and aggressively you are increasing marketing budget every month, why is this happening? Why sales is not going anywhere? Yes or no? This question came. So maybe we will try to answer that question, and that is done by diagnostic analytics. So maybe you can break up your budget and maybe you can look closely into that way. What are the mediums? Remember that? Maybe I took that example. Array, yes or no? Did you see this graphs? Did we talk about this? Remember, right? So what we are doing wrong? Maybe we will try to answer that. Why this is happening? Why this cannot happen some other way? So think about it. We know what has happened, and now we are trying to find out why it has happened. What could be the next question of our CEO, ma'am? What can she ask next? She is a gentle lady. Earlier CEO, he was a rude person. He fired you from the job. But in this scenario, well, there is a nice lady and she is very gentle and she is just curious. What could be her next question? Maybe her question would be, yes, exactly. What seems, yes, what seems to be its impact in near future? What is going to happen? We know what happened. We know why it happened. Maybe she will ask, what is going to happen? What will happen, or at least what is most likely to happen? What my data is telling me. Correct? That's where we enter the domain of predictive analytics. What we try to do is just like this. You will get the video, but you may take the screenshot if you wish to. So there are various properties listed here of predictive analytics. What this step does exactly. So broadly, it is answering the question: what seems like to be happening in the near future. Near future is the keyword, not very distant future. Oh, coming to that. For example, for example, well, this is an old slide. Maybe I will have to update this. But suppose I have data from 2000 to 2005, 2015. I have this data of say 15 years, 18 years, 17 years, and then somebody is asking me what is going to happen next in near future, in next year or next to next year, maybe. What can I see? I have already seen this trend happening. What about this orange bar? This. So this is almost flat. Maybe it will, somewhere it will go, somewhere it will retain. This goes like zigzag. So maybe the zigzag will continue. Black bar goes like this. So yes, there is a mild increasing trend in black bar. Black bar is for newspaper. Okay. Yes or no? There is a slight increasing pattern. So maybe it will continue. What happened to internet? I have seen for last 15 years. What has happened with internet? This has started and it grew exponentially. हाँ increase तो है. There is increase, but it is exponential increase. So what can I say for next year? What will be the scenario at the financial year closing of 2021? Yeah, most probably this increase will continue. Yes or no? I have seen this trend happening for last 15 years, 18 years, 20 years. So maybe for next year I can be very sure it is going to continue. So this is a very crude definition of predictive analytics. We do some mathematics. So can we predict like that? Yes. As a matter of fact, we have very powerful algorithms and with some cool tricks, of course, we can predict for a near future. Now, near future, why I'm saying near future is the key? From these 20 years, I cannot predict next 20 years. Getting the idea? If I have data of last 20 years, I should not predict next 10 years or 20 years. So that is something key here. But yes, if I have ample data at hand and relevant data at hand, maybe I can predict next 1 or 2 or 3 years. Okay. So now is the time when we are entering the domain of predictive analytics. And now is the time when there will be some deep, not deep, but there will be some practical mathematics happening. What happens? How does the idea sound? We are going to learn statistics and we are going to learn geometry. These two branches of mathematics are of paramount importance in predictive algorithms. Because when we will start building these models, so there will be broadly two kinds of models. There will be statistical models. When we will be building predictive models, so there will be broadly these two categories you will be facing. And there will be distance-based models. Distance-based means geometric distance. What do we call that specifically? We call it Euclidean distance. Heard of it? How many of you have not heard of the name Euclidean distance? It will give me a fair idea. It is for your own good, so please ping. Those who don't know, please tell me. I will know what to do. Euclidean distance. Never heard of it? Okay. How many of you, which one of you has not been into mathematics after 10th? Up to 10th? Well, it was a forced choice. You did not have a choice, really. So as a slave, you have to keep a maths notebook. But after that, there was a choice. How many of you dropped maths there? At the first instance, when you had a choice, you dropped maths. Is there anybody? One such? No, nobody. That's surprise. Okay, very fine. So I am assuming everybody has learned 12th level maths. Anybody who has interaction with maths in graduation? Anybody? One such? Those who have interaction in maths after after their school in graduation. Okay, I see many of you. I see most of you. Wow. Anybody who did not have any interaction with maths after 12th. Up to 12th, I am assuming everybody had. Who did not have maths with them in graduation. Mathematical economics, well, that is more or less maths, Shubhangi. Anybody else who did not have maths in graduation? Anybody who did not have maths in graduation? Now, this is surprising. Really surprising because many of you shouted out that you don't know what is Euclidean distance. How come? Everybody here is who is having interaction with maths till graduation. Well, how thorough. How profound. Maybe you can think it that way, Abhimanyu. What is Euclid's theorem? Euclid's theorem. What is Euclid's theorem? It is not theorem with it, basically. I have a geometry. What is geometry? X-axis and y-axis. X-axis and y-axis. I have a data point. Let's call it. What do I want to call it? Let's call it x1 and y1. I have another data point. Say here. One is here, one is here. This is x1, y1. This is x2, y2. What is the distance between these two data points? What is the distance between these two data points? That is called Euclidean distance. Three dimension is far from far from discussion. Sonam, let's deal with 2D first. 3D we will uh, you know 3D is far from discussion for now. Hanji, what is the distance between these two data points, P1 and P2? We are not going into anything for now. I am just explaining. So that is what is termed as Euclidean distance between these two data points. How it is calculated? What is the formula for this? It will be x1 minus x2 plus y1 minus y2 square and square. And this entire thing is taken as square root. This is what we are calling that this is the distance between these two data points P1 and P2. This is how it is calculated. Acha, anybody having doubt? X1 minus x2. Should we do x1 minus x2 or should we do x2 minus x1? Or you do anything, whatever you like. How does it matter when you are squaring it? Yes or no? This would be the difference. It may be positive or negative, but once you square, all null and void, it would be square only. Everybody getting this so far? Pratham, could you please ping me? I'm specifically worried because you have already raised concern. So, you know, I want you to be on the same page. because for now it is mathematics. It has nothing to do with our codes. What we are trying to do is, before I come back to coding, I want to give you some time. So this is maths. I will keep explaining maths theory, and it is relevant, which will come in predictive analytics. Meanwhile, you can revise the coding part. Okay. Now, since for now there was a strength was way too high of this batch, because it was mix and match of several students from the two locations, Delhi and Bangalore. But currently it has been like that. Those who are able to be, those who are keeping up with me, they are with me, and those who are facing trouble, they will be trained by another trainer. So you can think about that also. But your location is Delhi. I would recommend you to stay with me. However, doesn't matter how much you hate me, but it is for your own good that if you stay with me, because you belong to Delhi location. I'm saying this because once we resume classrooms, and once we are opening the centers are fully running, so you will be interacting with Delhi centers, and eventually for interviews and for resume preps and everything, you will be dealing with Delhi center. Okay, fine. Okay, very fine. Getting back to the maths we are trying to learn. So that is Euclidean distance. So we will deal with these things time and again. I will drop you some links just to brush you up. Okay. So just get back on your feet for this basic geometry, basic statistics. कुछ कुछ मैं डिस्कस करूंगा, कुछ कुछ आपको पढ़ने को दे दूंगा. ठीक है, so that we are able to run it quickly. However, because uh, because many of you have said that, and honestly speaking, I knew that it is going to happen to a certain level, that you will not be very handy with that maths. You have studied maths, but and it is certainly it is going to help, but obviously you don't remember it. I would not remember whatever I learned in my graduation or post graduation. I only remember these things because I am in constant touch. That's it. So to just walk you through quickly, we will done some mathematics. Meanwhile, I will, but I also I try to alarm you that things are going to be a few notches up. Now, notches up. It is not that you will not understand, or this is something beyond the world going on. It is not that, but it is that you have to juggle several balls at a time. You have to study mathematics also. You have to cope up with the coding part also. So ऐसा नहीं होना चाहिए कि maths you are reading studying maths and you begin to forget your EDA part which you have already learned. Okay, so both things have to be in a certain practice. Fair, good. Shall we? Shall I begin? Capua, Capua. Shall I begin? How many of you have seen this series? Watched it? Anybody? Recon it? चलो छोड़ो, पढ़ लो, देख लेना सीरीज, बहुत टाइम मिलेगा. Statistics. Now again, before I begin, one more thing I'll say just now. We are not going into PhD level mathematics. Okay, so don't worry about that how deep we are going. right? We will learn mathematics which is useful for us in data science. So mind you that data science, maths is pivotal for data science, but data science goes way beyond. So statistics will broadly have two branches. One is descriptive statistics, which we will find out. What is descriptive analytics? It is to describe the data. Every now and then you are talking data, data, data. So the statistical measures which are used to describe the data are known as descriptive statistics. For example, within descriptive statistics, I need something to describe my data. For example, if I say, what is the age of this batch, PGA 9 Delhi or PGA 16 Bangalore? What is the age of the people in this batch? So how do I answer that? How do I answer that? I will start telling Abhimanyu age is this, Aditya's age is this, Mansi's age is this, Nikhil's age is this, Sonam's age is this. Should I keep doing that? Should I go on? So, not exactly. Yes. So that's what I need. What do I need? I need a single point representation of entire data set. This is called measures of central tendency, or simply sometimes called central tendency. So how can I measure the central tendency of a data set? One which is very popular, you already have mentioned, many of you. So what can be the measure of central tendency? Same example. I want to represent this batch's age by a single point representation. So one could be obviously mean. Many of you have mentioned that. But what is mean? What is mean? Mean is mean is nothing but arithmetic average. It is as simple as that. Yes? Sum of all the values divided by number of values. The simplest form. The simplest central tendency. So I will add up all the ages of my students here and I will divide by number of students and be done with it. So that is central tendency. Very fair. Simple. Another central tendency could be median. What is that? What is median and how is it different from mean? Excellent, Ashutosh. So median is the middle value in a set of values. Suppose I show you a set of values. Suppose there is this set of values. तो mean क्या होगा इनका? सबका टोटल कर लो और डिवाइड कर दो नंबर ऑफ वैल्यूज से, है ना? तो वो तो हुआ मीन. मीडियन क्या होगा? अरिथमेटिक एवरेज. नहीं, वो तो मीन था. मीडियन. मीडियन क्या हुआ? सेंट्रल वैल्यू, मिडिल वैल्यू. 1 2 3 4 5 6 7 मिडिल वैल्यू. सही बात है. हाँ, वही सोच रहा था. कितने लोगों को समझ में आ गए? 26. 26 is not the middle value. We don't say middle value this way. This is data set. First you have to sort this data set in any order, maybe increasing or maybe decreasing, that won't matter, but it should be sorted first. Now middle value. समझ में आ रहा है? You will not make this mistake, promise, because you make these mistakes. Yesterday, PGA student did that in mock interview. Just yesterday, a PGA student of Mumbai branch. I was interviewing in the capacity of external trainer. He did that. Middle value? I asked a similar question. Middle value 26. Daएं. Fire. I gave him a minute to think about it. No, not at all. 26. Okay, go ahead. You say दाएं, I say 0. सही है जी? You will not make mistake. You will not make this mistake. You will not make me walk the hall of shame, strutting around, because I taught you this. Very fine. But okay. So these were 7 values. So fourth value is the middle one, that is 21. What about if there are 8 values? Now which is middle value? Which one is middle value? Actually there are 2 middle values now. So what would be the median? 21.5, 22.5. Anybody else? Abhimanyu, correct. Ashutosh, wrong. How? How it is 21.5? Because it is arithmetic average of the 2 middle values. Then that will be the median. Fair? When there is odd number of values, the middle value, it is easy to find. It can be this. When it is that there are 2 middle values, because total number of values are even, so there will be 2 middle values. So the final median would be the mean of these 2 middle values. Okay, everybody got this? Fair? Now some MCQ stuff for you people. The trick questions for MCQ stuff, or aptitude kind of thing. And trust me, you people make these mistakes. I don't know. Because सुनने में बड़े आसान सी चीज़ें लगती हैं, लेकिन जब वहाँ पर होता है ना, धड़ाक से टिक मार देते हो और आगे चले जाते हो, सोचते ही नहीं हो क्या कह रहा है क्वेश्चन. Listen to my question and answer in true or false. Mean of a set of values will essentially be a value in the set. The mean value in a set of a set of values of a data set would essentially be a value in that data set. True or false? Are you getting it? Yes, obviously. If I calculate mean of these values, it may come something like 22.6 or maybe 21.6. So this value is not actually present in the dataset. Anyway, it is mean of this dataset. So false. Question number 2. Median of a set of values will essentially be part of that data set, a value in that data set. True or false? हाँ देखो मिला ना, मिला एक होनहार. क्या कह रहा हूँ दोबारा सुनो. आई एम सेइंग मीडियन ऑफ अ सेट ऑफ वैल्यूज इज एसेंशियली पार्ट ऑफ दैट सेट ऑफ वैल्यूज. मीन का आंसर करना आसान है. नाउ दिस वन इज ट्रिकी. देखने में ऐसा लगेगा क्योंकि एकदम से पहला ख्याल तुम्हें यही आएगा जो दिखा रहा हूँ कि हाँ मीडियन इज मिडिल वैल्यू. तो मिडिल वैल्यू कोई ना कोई वैल्यू मिडिल होगी डेटा सेट में, और जो भी होगी वही मीडियन होगा, तो पार्ट ऑफ डेटा सेट हो गई. ट्रू. मारोगे धड़ाक से. व्हाट अबाउट दिस? ये भूल जाओगे उस समय. सो median is middle value, very fine, but is it essentially part? Not essentially. It may be, it may not be. हाँ किसने मारा था ट्रू इस पे? निखिल. निखिल ने परहैप्स. ठीक है. अब एक बात बताऊं. अब बाकी तुम में से कोई भी गलत कर देगा, निखिल गलत नहीं करेगा इसको. इट हैज दैट इम्पैक्ट. एक बार क्लास में जलील हो जाता है ना कोई, उसे ध्यान रहता है फिर. Okay, fine. Okay, fine. So no hard feelings, Nathan. It was not. It was not to mock you. In fact, you know me by now. I keep doing these kind of things. Okay, very fine. But why we are calling it central tendency? Median is arithmetic average. So that is understood. Why median? In what sense median is central tendency? Median is central tendency in the sense that since it is middle value, why we are calling it central tendency? Because it has 50% people below this and it has 50% people above this. Yes or no? That's why it is middle value, no? Not this one. Matlab, I am just taking example. I have not sorted it this time. I am just showing you for the sake. So let's, in fact, we can call it something else. So in that sense, it is central tendency because it is in the center. It has 50% of the data below it. It has 50% of the data above it. Which brings me to the next question. Next central tendency, that is, yes, you people have correctly mentioned, mode. What is mode? That appear most times, right? Most common value, most frequent value. Yes, uh, by whatever vocabulary you want to identify it, that is what it technically is. It is the most frequent value. If I have this kind of data set, getting this. So irrespective of that what has been the value, it is most occurring value, repeating several times, repeating maximum times. So say some are appearing once, some are appearing twice, some are appearing thrice, but 24 is appearing some, 6 times. So what is the mode here? In this case, mode would be 24. It is as simple as that. Okay, by the way, same MCQ. Mode of a data set is essentially a value in that data set. True or false? हाँ, अब की बात ट्रू है, बिकॉज बिकॉज मोड को फर्क नहीं पड़ता. मोड डेटा, अरे डेटा सेट में होगा और मल्टीपल टाइम्स होगा तभी तो मोड बना है वो. सो दैट इज वाई ट्रू. समथिंग एल्स, अ डेटा सेट कैन हैव मोर देन वन मोड्स. ट्रू और फॉल्स? अरे ट्रू. फॉल्स क्यों कह रहे हो? देखो 24 भी 4 टाइम्स आ रहा है और देखो 21 भी 4 टाइम्स आ रहा है. सो इसका मोड, इसमें 24 भी मोड है और 21 भी मोड है. सो ऐसे डेटा को हम क्या बोलते हैं? वी इट इज कॉल्ड बाय मॉडल. देयर आर टू मोड्स, बाय मॉडल. So there can be bimodal datasets, bimodal, trimodal, multimodal. It is possible, okay, because they have multiple modes. Okay, coming to something else. I think you have the clarity. Anybody, any question? Because if you don't question, I will start question. Okay, okay, बढ़िया. Now I am questioning you. This is the data set, and as we see, very simply, we can call 24 is the mode. Now I am asking you, how come mode is central tendency? Don't you think it is not necessarily center by any means? 24 is not center. In fact, it is the highest value in this data set. It is just that it is frequent. Why we are calling it central tendency? Remember, central tendency is single point representation. In that context, can you figure it out? Uh, most of them are 24. Okay, so what, Monarch? It is most frequent and we use it because it could be a possibility. Okay. And Jyoti, you got the idea. Your idea is right. You are just using, you are just not using the exact word. Okay. Okay. Understand, guys. Think about it. If most of them are 24, the average tends to be near to 24. Abhimanyu, not necessarily. एक बात बताओ, अगर एवरेज टेंड्स टू 24 एंड दैट इज व्हाई आई एम कॉलिंग इट इज 24, इससे अच्छा तो फिर वही ना बता दूं. फिर मैं मीन की बात करते हैं. फिर हम बात ही क्यों करें? मैं वही तो पूछ रहा हूँ. मैं व्हाई वी आर टॉकिंग अबाउट मोड? आई ऑलरेडी हैव मीन एंड मीडियन. It becomes central tendency. Okay, understand. Try to understand it. I hope you will get it by that example. The example which we took, the average. I am trying to find a central tendency of your batch to represent age of you students. So mean, well taken. Median, well taken. If this is median, then well, in what sense I am saying central tendency? That what is the central tendency of my batch? 21, because half of them are below that and half of them are above that. So that's very fine. Mode becomes central tendency in the sense it may not be a middle value by any sense, but what I am saying that most of them are of this age, some are with different age. That is why mode is central tendency. Making sense? I am saying most of them are of this age, others are okay, maybe some nitty-gritty difference. Now I am putting it other way. If I put it in other words and tell me if you are getting it, I am saying now I am talking in technical definition. If I randomly choose a person from this group, the highest probability would be that he or she would be 24. Let it sink in. Think about it. Is it correct? Am I making sense? Okay. So in that sense, mode is also central tendency. So there can be three kinds of central tendency: mean, median, mode. The three M's. I hate them. I'll tell you. I'll tell you in subsequent sessions why I do hate them. So let's define them quickly. Mean is arithmetic average. Median is mid value in a sorted order. So that is key here. And mode, well, simply the most frequent value, the most occurring value. Among all these, mean goes a long way because mean is by far the very sensitive central tendency. We will see that also soon enough. So that is one part of descriptive analytics, that is measures of central tendency. I hope you got that in detail enough. Now I am saying something that why I needed central tendency to describe the data. It is descriptive statistics. But is the central tendency enough to describe a data? What do you say? Is this central tendency enough to describe a data set? Let's see a scenario. Let's see a scenario. Say this is a data set. वही मार्केटिंग बजट और सेल्स, कुछ मार्केटिंग बजट हुए हैं, कुछ सेल्स हो गई है, अभी सेल्स में इंटरेस्ट है हमारा. Think about it, what would be the mean of this data set? I think roughly say this is the mean of this data set. Yes or no? I'm just trying to make you visualize things. This is a data set and this is a data set D1, and it has a mean, say mu1. Mean is represented by a Greek letter mu. Say now there is another data set. What is that data set? Pay attention, the data set has changed. Now this is a different data set. Yes or no? The data set is different now. It is a different data set. I am calling it D2. However, it seems likely that mean is still the same. Yes or no? Possible? So the two data sets are not equal despite they are having equal means. So that is why I say central tendency is not sufficient enough to describe a data set. As you see, it is happening. As this be the case. What else do you need? Anybody? You need something else also. ये सब पढ़ रखे हैं तुमने, यकीन मानो पढ़ रखे हैं, लेकिन समझ नहीं आए थे उस समय क्यों कर रहे हैं सब ऐसी बात हमसे। आज समझ आएंगे ये सब बात, आई प्रॉमिस। You need standard deviation, you need variance, you need quantile, you need anything else? Anything else do you want to say? Yes, we need something, and they are called measures of dispersion or measures of scatter. डिस्पर्शन ही रखो, कभी कंफ्यूज हो जाओ। एक ही बात है, वैसे पढ़ाई मिल जाए कहीं मेजर्स ऑफ स्कैटर बोल दे कोई तो घबराना मत उससे, सेम बात है। ओके, so let's break for a while here and we will continue with measures of dispersion next. It's 11. It's 11:03 by my clock, so let's resume at 11:13. Okay, guys. So some 10 minutes break. Go ahead, stretch yourselves, grab some water, and be back in time. See you there. Hi again. Hope everybody is back. Please ping me those who are back. Okay, so most of you are here. Very well. We talked about measures of dispersion. What is measure of dispersion? Suppose this was sales on y-axis and there was, for that matter, any data, sales, age, salary, whatever you want to call it. This is my data set, and I am having some values here, this, that, this, that. Why do we need a measure of dispersion? Because central tendency is not enough, we just established that. So say, what would be the mean value? I think here something like this would be the mean value of this data set. Let's assume for now, so I'm calling it the mean value of this data. What are measures of dispersion which you have mentioned? So one of the measure of dispersion is variance. Somebody said it. And what would that be? I am saying let's measure how much this data is scattered from mean value. Central tendency I have found out, that is mean. How much this data is away from the central tendency. So let's find out. Hanji, how much this data is away from mean value? I think this, if this is the point P1, X1, Y1, maybe we call it. Yes or no? The distance from mean value is this much. For this point, the distance from mean value is this much. So say this is point P1, this is point P2, right? This is mean value y, or maybe call it y-axis. We represent mean value by bar also. So what is variance in this case? I am saying let's see the distance of data point from mean value. So what would it be? I think y1 minus y bar, or I am calling it mean value mu. Yes or no? Now sometimes what will happen? Now this point is below mean, so this value will be negative. On the other hand, sometimes point will be above, like y2 minus mean, like point 2. This point is above mean value, so this value is going to be positive. I don't want uh, this dilemma happening every now and then. So let's do what? Let's square them. Very fair. Yes or no? So this is dispersion of point 1, this is dispersion of point 2, and we have squared them, and we have taken for all the points like this, y1, y2, y3 up to yn. And then I divided by number of values. How many data points are there? That becomes my variance. So that shows me how much my data is scattered on both sides of mean value on and average. Divide कर लिया ना इनसे, so on and average. Sounds good? If I generalize this term, how can I generalize it? How can I generalize it? I am saying that variance is equal to what? Not y1, I am saying I am denoting it by yi minus mean square divided by but along with what? And I'm denoting it by what? What do we denote it with? I'm saying summation. Summation for all possible values of yi. Any confusion here? Everybody got this? We wanted to find out a measure of dispersion, that how much my data is scattered. यही प्रॉब्लम हुआ था ना, जब दो तरह का डेटा आया, मीन सेम है, तो किसी तरह से तो पता चलना चाहिए कि ये these two data sets are different. So let's see how much this data is scattered. So there were two data sets. One was this. Another one was something like this. I found out it has a mean mu1. It also has mean mu1, mu2 are equal, which are equal. But measure of dispersion. What is measure of dispersion? What do you think? Which data set has more variance? जिसका स्कैटर ज्यादा होगा. Yes or no? Variance वहीं पे ज्यादा होगा ना. So despite means are equal, variance we denote by sigma square. Greek letter sigma square. So which variance is high? Second one seems high. So now you can differentiate that these two data sets are different. Despite mean is same, but variance is very different. N is number of data points. Yes, Ashutosh. I is just a variable. Summation mein I am denoting it by that I am taking y1 this yi minus y mu how many times, that I will keep varying. It will start from 1 and it will go up to 1 n. So for each value of I there will be y1, y2, y3, y4 and so on, and then I will sum it up. That is the meaning of this. Okay, so maybe you can use a bracket here. Clarity? Question, confusion, anything? Example with numbers. Okay, I'll try to come up with something. What should I take? Okay, let's see. Okay, let's see. I'm creating a vector v1 which looks like this. If I check mean value, it is like this. There is another vector v2, and this is a, what do you say? They are very different things, two different vectors. If you want to print them, you can see the printout there. Getting it? There are two different set of vectors. They have different number of values. Mean is same. Different set of values. Mean is still 15. How will you identify whether they are different? Okay, maybe either you are able to visualize it. So visualization can give you an idea, but not actually the values. This is the plot of first vector. You don't worry about my code for now. Okay. So code I am doing just to show you some differences. What do you see? Two very different vectors, two very different set of values, despite having the same mean. Yes, no. तो कैसे पता चलेगा? Mathematically कैसे पता चलेगा? How will you find out? Let's find out variance. So variance of v1 vector is 11. Variance of v2 vector is, oh goodness, 82 something. Yes, mean value से बहुत ज़्यादा scattered है data this time. Fair, Muzammil, I hope you got the point. What I was trying to, what I was trying to explain pathetically by digital pen. Maybe our studio came to help. Perhaps it is a tad bit better now. Okay. So this is one measure of dispersion. Another measure of dispersion, which also one of you mentioned. What is the standard deviation? There is something, the standard deviation. Under root variance. Somebody is sitting correctly. Yeah, it is correct. What was variance? Variance was this much. So you got how this formula is derived. This variance formula, it is to explain the scatter in the dataset. It is not that Mr. Gauss decided one day that I got brains, let's create एक गंदा सा फार्मूला बनाता हूँ जो बच्चों की नाक में दम कर देगा, सिलेबस ही पढ़ा दूंगा हमेशा के लिए. Not like that. It is there for a reason. Then there is something called standard deviation, and what is that? Standard deviation is just the square root of variance. That is why it was represented like sigma square. If this is sigma square, what is sigma? What is sigma? Sigma is standard deviation. So I think no particular point explaining this. in detail again. हाँ, यहाँ पे स्क्वायर करके ऐड किए थे, तो स्क्वायर रूट ले लो। ऐसे तो सोचा होगा किसी ने। Any questions? None? Everything going fine? Because if you don't ask, I am going to ask something. We already know there is something called variance. Okay, this is this. Then there is something called standard deviation, which is just square root of variance. So maybe this is square of this, and maybe this is square root of this. Why this nonsense? Why this kind of nonsense we are doing? When I have one measure, I can use that. हाँ, वही बोल रहा हूँ अभिमन्यु, there is no particular difference. Variance is sigma square and it is calculated, the formula is this. Standard deviation is the same thing. It is the same thing, but it is just the square root. The square root of this value, this summation. Everything is same, just it is taken as the square root of this value. So why two different terms for more or less the same thing? I wanted to measure the dispersion somehow. I have measured. देखो, central tendency, when it was central tendency, these three things mean very different. Yes or no? These three are very different things. These are three genuine different methods to see the central tendency of a dataset. What is the difference between these two? They are more or less the same thing, just with a tweak of maths. Nobody? None? चलो, let's leave it for now. सोचना थोड़ा सा इसके बारे में. Think about it, and we'll come to this question again. Then there is another measure of dispersion. So these are the two things which are in context of mean. If I am thinking of mean as a central tendency, then measure of dispersion can be variance or maybe standard deviation. Well, fundamentally, no difference than square or square root. Variance could be a higher value. हाँ तो ठीक है, हायर वैल्यू है तो स्क्वायर रूट ले लेते हो क्या हर हायर वैल्यू का? भाई अभी अभी तो देखा था हमने, वेरिएंस कैलकुलेट की तो इसकी आई 11, इसकी आई 3. तो स्क्वायर रूट कर लूंगा, क्या फर्क पड़ गया? हाँ तो इनका कुछ स्क्वायर रूट आ जाएगा, ऑफ कोर्स छोटी वैल्यू होगी, लेकिन लेकिन स्क्वायर रूट लोगे तो दोनों का ही तो लोगे, तो अब स्क्वायर रूट में उतना डिफरेंस आने लगा, इनके डिफरेंस, क्योंकि तुमने स्क्वायर रूट कर लिया था। चलो वापस आएंगे इस पर किसी दिन। Then there is something called, because agar measure of central tendency you are considering median, so with respect to median there can be central tendency. What is that? Somebody mentioned that also. It is interquartile range. So what is that? Suppose I have a data set. So this has to do something with percentiles actually. Heard of the name percentiles? Do you realize there is a difference between percentiles and percentage? They are two very different things. Percentile is always about population. वो कैसा होता है? Suppose आप में से किसी ने, if you have appeared at cat, sat, mat, something, you know their result is in percentiles. How do they call it? That the topper's percentage is considered as the 100th percentile because that is the maximum achieved by someone. Paper may be of 100 marks, your topper might have got 40% marks, but still it is 100 percentile because that is the maximum possible. Nobody achieved more than that, right? So how percentile is calculated is, suppose there is a set of values. So we are not bothered about number of uh, number of values. Suppose these are x2, x3, x4, and so on up to say xn. So these are n number of values, and I am not worried about how many values are these. These can be a few hundreds, these can be a few millions, right? So percentile is the idea that if I divide this population into 100 parts, what I am going to see. What I am going to see. Suppose these are the values, and we are also let's assume these are in sorted. These are sorted in ascending order. So x1 being the minimum, xn being the maximum. And we are not worried about what is xn. What is n here? N can be 100 or 1000 or million. So what will be the percentiles here? What is the idea of percentile? I am saying this is the maximum value. Means none of these values is greater than this value. In this set of values, nobody is greater than xn. So in that sense, this becomes my 100th percentile. All the values, 100% of the data is below this value. So this becomes 100th percentile. What do you say to xn? X1. This is the minimum value. So this becomes my 0th percentile. In the sense, yeah, nobody is below this point. सभी इससे बड़े हैं, सभी इसे पीट रहे हैं. So there is zero values below this point in this data set. So 0th percentile. Okay. Now going to another level. In these n values, there would be some data point. कहीं तो कोई data point ऐसा होगा which will be 25th percentile. Yes or no? Means 25% of data is below this point and 75% of data is above this point. So that becomes my 25th percentile. In other words, I am calling it first quartile. Q1. You got this idea? Also, there would be somewhere in this data will come, I'm calling it XP. Somewhere in this data will come a value XP, which will be what? 75th percentile. Means 75% of data is below this value and 25% of data is above this value. I am calling it third quartile Q3. Got this? And if that be the case, what will be interquartile range? Interquartile range would be equal to Q3 minus Q1. Q3 minus Q1. Obviously, Q3 will be greater value, no? Or a third quartile would obviously be greater than first quartile. They are in sorted order. Then we are talking to these percentiles. Okay, so you see, so despite I am not worried about number of values, I can talk in terms of percentiles and interquartile range. Uh, Shortly, we call it, what do we call it? What should we call it? IQR. So that is Q3 minus Q1. So this is also a measure of dispersion. If you are talking in terms of, if central tendency you are considering median, then we consider measure of dispersion as IQR. Fair? Any question? Simple? Now tell me, what the hell has median to do here? What the hell has median to do here? Why we are saying that we will consider IQR as measure of dispersion if central tendency is median? Because 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 it is a range of numbers. So what? Because Q3 minus Q1 is 50% or mid value. Now that is the worst idea you can get. I was expecting somebody will do that. Think about it, guys. Q3 minus Q1, is it median? What do you think? Q3 minus Q1 is essentially median. I am saying IQR means median. Is it true or false? What do you have to say? Not necessarily. It is something way too different. किसी डेटा पे करके देखना है काम, छोटे से डेटा पे देख लेना, पता चल जाएगा। दिखाऊं? अभी दिखाऊं? चलो देखते हैं। there is a data and okay, it is actually, मैं कह रहा हूँ empty cars का ले लेते हैं, क्या ले लेते हैं, चलो miles per gallon column ले लेते हैं. So this is my data. This is my data. ऐसा कुछ सिनेरियो है. देखना जरा. Summary of vector tells me everything. ये तो आप कई बार देख चुके हो. अब समझ आ रहा है फर्स्ट क्यू, थर्ड क्यू क्या क्या बताता था ये समरी फंक्शन. Shubhangi, is it okay now? I see you have dropped many times and joined back many times. Shubhangi, how is your connection now? Okay, but I think Shubhangi, it is problem at your end because everybody is getting just fine. All others are getting along. So, well, what do I say? Try to tweak your connection, or maybe anyway you are going to receive recording today itself. So maybe there you can follow. Well, others, this was minimum, first quartile, median, mean, third quartile. I was asking you what has median to do with IQR. Think about it. If this is Q1 and this is Q3, where is Q2? Who do you think is Q2? Yes or no? अरे यही तो है वो. What was the idea? That 25% data, if there is 25% data below this point, it is Q2. If 75% data is below this point, it is Q3. Who is Q2? Q2 is where 50% data is below this point and 50% data is above this point. और वो कौन होता है? मीडियन ही तो होता है. ठीक है जी. Let's find out another thing. Somebody said, अगर मैं IQR, if I am calculating IQR, which is Q3 minus Q1, तो वो तो मीडियन ही होना चाहिए. और देखते हैं होता है क्या. Q3 minus Q1. What do you get? Is it equal to median of empty cars miles per gallon? What do you say? Not even close. Not even close. They are very different values. Okay, ji. So this is somewhat of descriptive analytics, which we have talked about. I have kept it slow so that you can pace it up later. But I hope it was a brush up kind of session and कुछ certain idea मिल गया होगा. हो सकता है कुछ ऐसा भी दिखा हो जो रट लिया था उस समय लेकिन दिखा नहीं था. It happens. It happens with many students, and that's why I'm saying it. It has happened in the past. पढ़ रखा है, फॉर्मूला पता है. No idea where it came from. Before we depart, I'm dropping you a link. Here in the chat box. So this is a link to download an ebook. It is an ebook by a legendary mathematician Brian Caffo on statistics for inferential statistics. Today we saw descriptive statistics. Well, that was just the basic part. The actual fun begins when we come to inferential statistics. So you have LMS content, you have this ebook. I would request you people to start going through these things and your LMS content also. See, the way these modules are designed is that self-study is a very integral part, and for that purpose you have LMS modules, which are self-paced, by the way. But start giving time to that. Okay, everything cannot be completed in classroom. So we don't feel bad about it. This is the way it is. Everything could not be covered. We can go up to next December 2021 if we start covering it each and everything here. In case you feel a problem, in case you are confused somewhere, then you have every right to get back to me. No problem at all. But I am very much sure that 80% of the module which is for self study, you will be able to gather it. Fair guys. So this ebook maybe it is for statistical learning, and you can start reading this as well. It is freely available. I don't know how much comfortable you are reading an ebook. Honestly speaking, I am not. I like the feel of the paper when I read. So ebooks don't excite me much. But anyway, you know the book, you know the author. If you're not very comfortable, maybe you can purchase it from Amazon. But it is a fantastic book to have. Very well, guys. So I think we are all set for today. I'll see for some links which you can start referring for your self-study kind of thing. Tomorrow after session, I will give you some links and some topic names about which you can go online and research. Very welcome, everybody. Signing off for today. Bye all and take care and start going through some mathematics fun. Okay, guys, very welcome. Bye bye. Take care.